Hey guys, it's Olivia. Welcome back to your endocrinology chapter. In this chapter, we'll be discussing the function of the anterior pituitary. The anterior pituitary, or the adenohypophysis, is going to be that front part of the pituitary that arises out of Rathke's pouch, that evagination upwards, like we talked about, of the foregut. And the anterior pituitary is going to release several hormones that we'll talk about in this video. It's going to release your sex hormones, like follicular stimulating hormone and luteinizing hormone. It's also going to release adrenocorticotropic hormone. It's going to release our thyroid stimulating hormone. It's going to release prolactin as well. And then finally, it's going to release growth hormone. And we'll talk about the regulation of these hormones as well as all of their functions when we dive into the individual pathways. I like to remember all of these hormones that the anterior pituitary releases by using the mnemonic flat PG or flat pig. So F for follicle stimulating hormone, L for luteinizing hormone, A for ACTH, T for thyroid stimulating hormone, P for prolactin, and G, of course, for growth hormone. And that just kind of helps me remember which of these hormones are going to be released from the anterior versus, let's say, the posterior pituitary. Now, before we dive into the individual pathways, I want to talk about just kind of the general regulation of how these hormones are going to be released and the kind of formula that is going to control release of hormones from our anterior pituitary is usually as follows. So we have our hypothalamus. Our hypothalamus, remember, is located in your brain. And then our hypothalamus is going to release certain signals, certain hormones into this portal circulation, this portal pathway, these veins that are going to be a highway from the hypothalamus to your anterior pituitary. So these hormones from the hypothalamus jump on the expressway to the anterior pituitary, and then they signal the anterior pituitary to release another hormone. This hormone is going to travel to our end organs, and then that is where it is going to exert its effects. So we're usually going in all of these pathways from the hypothalamus, signal, anterior pituitary, signal, end organ, and then the end organ exerts its effects. So let's see that in action with our first pathway when we're talking about luteinizing hormone and follicle stimulating hormone from the anterior pituitary. So I'll zoom in over here on your slide, and you can see that we're starting with the hypothalamus in the brain, as I just mentioned. And from the hypothalamus, we are going to have gonadotropin releasing hormone. That's going to be the first hormone that's released. Gonadotropin releasing hormone is going to travel through that portal system to our anterior pituitary. We hit our anterior pituitary, and that is going to stimulate the anterior pituitary to release luteinizing hormone and follicle stimulating hormone. Now, these are going to travel through the body, through our bloodstream, and travel to our distant organ, which in this case are the ovaries if we are in the female, the testes if we are in the male. On this diagram, we just included the ovaries, but be aware that this would be the testes if we were in the male. And at this end organ, the ovaries or the testes, that is where luteinizing hormone or follicular stimulating hormone is going to promote the release of estrogen or progesterone in the female, or testosterone if we were in the male, in different amounts. And then you can see that the end result of this pathway, our estrogen or our progesterone, those are going to be responsible for the regulation of this pathway. And in the female, as you can see, it's a little bit complicated. We have both negative and positive regulation. Progesterone is going to be our negative regulator, where it is going to be shutting off our hypothalamus and shutting off our anterior pituitary and telling them not to make any more because we have enough. And estrogen is going to be our positive stimulator, saying please make more progesterone when it is high in concentration. There's a couple times throughout the female cycle that is untrue, but we'll not get into the minutiae of the female hormonal cycle in this video, but it's a great thing to check out in our reproductive unit. So that was LH and FSH. Now the next hormone from the anterior pituitary that we're going to talk about is ACTH, or adrenocorticotropic hormone. And if we zoom in over here on our diagram, we can put our pathway into effect. So first we start out with our hypothalamus. Our hypothalamus is going to release corticotropin releasing hormone. Corticotropin releasing hormone is going to travel through that portal system to the anterior pituitary, and our anterior pituitary is going to release adrenocorticotropic hormone like we just talked about. Adrenocorticotropic hormone is going to travel to the adrenal cortex. The adrenal cortex is located right here, right above your kidneys. That's why it's sometimes called the suprarenals. And your adrenal cortex releases corticosteroids into the bloodstream. Corticosteroids are going to then act through negative feedback and shut off this pathway. It's going to tell the anterior pituitary to stop stop making so much ACTH, and it's going to tell the hypothalamus to stop making so much CRH as well. So that's the effects of ACTH. ACTH is going to travel to the adrenal cortex and increase the release of corticosteroids, like we just talked about. One of the most common corticosteroids is cortisol, and the effects of cortisol, it can increase your blood pressure, it can stimulate central adiposity, it can also cause these purple striae or the buffalo hump when it is in too much supply in the body. So the release of ACTH from the anterior pituitary and subsequently the release of corticosteroids from the adrenal cortex, that's kind of the traditional effect of CRH that we all learn about, but I think it's important, at least for step 1, to also be aware of some additional effects of CRH in particular. So CRH also stimulates the release of beta endorphins as well as MSH, melanocyte stimulating hormone. So if we have too much CRH and that is causing the increase of melanocyte stimulating hormone, that is going to be one of the reasons that you might see darkened skin patches or increasing melanocytes in the dermis. Additionally, the POMC gene is going to be an important tie-in with ACTH here. So the POMC gene is made into the POMC protein, but that is a protein that is very large and is not yet ready to exert any end effects in the body. So it is subsequently cleaved into smaller proteins, and these smaller proteins are things like melanocyte stimulating hormone, again, and ACTH. And it's important to be aware of the fact that this ACTH is oftentimes coming from this POMC protein that when it's cleaved can also create MSH as well, because like we just talked about, this increase in melanocyte stimulating hormone can lead to some very particular physical exam findings that you might see on step 1. Now, the next hormone from the anterior pituitary that I want to talk about is thyroid stimulating hormone, which of course interacts with the thyroid. So if you zoom in down here, you can see, again, we're starting out with our hypothalamus. Our hypothalamus is releasing thyrotropin release hormone into our portal system. It's traveling down the portal system into our anterior pituitary. When it reaches the anterior pituitary, it is stimulating the release of thyroid stimulating hormone. The anterior pituitary sends thyroid stimulating hormone down to our actual thyroid, and then our thyroid is going to exert its effects of releasing T4 and T3. T4 and T3 are again going to act as negative feedback for this pathway, and then of course the end result is the release of these thyroid hormones, which can stimulate gene expression throughout the body. They also have very important roles in metabolism, heart rate, and several other processes as well. Now, the next hormone from the anterior pituitary that I want to talk about is prolactin. And if you look at our pathway down here, you can notice that this one's a little bit more complicated. One level of control is the hypothalamus, again, releasing thyrotropin release hormone, that same hormone that we talked about regarding our thyroid pathway. But this time it's going to the anterior pituitary and playing a role in stimulating the release of prolactin. Additionally, dopamine can regulate the release of prolactin. So dopamine here is going to be an inhibitor, and it is going to have negative feedback on the anterior pituitary to shut off the release of prolactin. In contrast to dopamine's negative effects, prolactin actually has positive feedback for itself. So the more prolactin that is released, the prolactin is going to travel back to the hypothalamus and increase signaling to the anterior pituitary to subsequently increase the levels of prolactin. So prolactin has positive feedback for itself, but dopamine is an important inhibitor of prolactin. And that is going to become important when we talk about several antipsychotic drugs that can change the levels of prolactin in your body. And there's several other important clinical tie-ins that we'll talk about in subsequent videos. Okay. Now, the final hormone that is secreted from the anterior pituitary that I want to talk about is growth hormone. And growth hormone is a little bit more complicated than our other pathways, save the best for last here, but it still follows the same general schema. So first we're going to have our hypothalamus, and our hypothalamus is going to release growth hormone releasing hormone. Growth hormone releasing hormone is going to travel through the bloodstream to our anterior pituitary. You can see that we have a really nice illustration of the portal system here that is carrying our growth hormone release hormone to the anterior pituitary. Our anterior pituitary is going to be stimulated to release growth hormone, and then growth hormone is going to exert its effects on several different organs. So growth hormone is first going to travel to the liver, and in the liver it stimulates the liver to break down glycogen into glucose, which is an important building block for growth. It also stimulates the liver to release IGF-1. So IGF-1 number 1 is going to go to all of these tissues like bone, muscle, nervous cells, and immune system cells and act as a growth signal. So it is going to signal those cells to grow along with growth hormone. And additionally, it is going to go back to our hypothalamus and inhibit the release of growth hormone release hormone. So when our hypothalamus perceives high levels of IGF-1, that is going to stimulate the release of growth hormone inhibiting hormone, and that is going to, of course, inhibit the further release of growth hormone from the anterior pituitary, thereby shutting off this system. So now that was a lot of pathways, but what are some key takeaways from this video? Well, the key takeaways are that our anterior pituitary is going to release FSH, LH, ACTH, TSH, prolactin, and growth hormone, and that the release and the regulation of all of these hormones is going to follow the same basic steps. So we're starting out with our hypothalamus. Our hypothalamus is going to release something. That something usually ends with blank release hormone. After that release hormone is released from our hypothalamus, that is going to travel through the portal system to our anterior pituitary. Our anterior pituitary is going to release one of these aforementioned hormones that we just talked about. That hormone is going to travel to an organ. Whatever the end organ is, that then is going to release another hormone, usually, or another signal, and then that signal is going to have end effects elsewhere in the body. That signal is also going to be responsible for the feedback. Prolactin is our special one that has more positive feedback, but the rest of these, it's mostly negative feedback. So that's good to be aware of as well. And then just generally knowing what the impacts of all of the end product hormones are in the body. Okay, so you've made it through this video, but how would they test you on this concept on step 1? Well, a way they might ask you about this concept is something like a patient presents with a rounded face, purple striae on their abdomen, some central adiposity, newfound elevated glucose, and elevated blood pressure. Okay, so what does that sound like to you? All those to me sound like symptoms that could be Cushing's disease, likely increased cortisol, so I'm guessing that we are in this pathway for this question. Great. The question goes on to tell us 24-hour urine cortisol is elevated, but ACTH levels are low. What organ is responsible for the pathology in this patient? Okay, so we know that we have increased 24-hour urine cortisol, so we know that this is increased, but what we don't know is this a problem with the hypothalamus releasing too much CRH and just telling this pathway to turn on? Is this a problem with the anterior pituitary that could also be just releasing too much ACTH and causing the adrenal cortex to turn on? Or is this a problem with the adrenal cortex just going rogue, not listening to any signals, and releasing a lot of cortisol? You don't really know just from the fact that we have elevated cortisol, because it could be a problem at any of these levels. And they will refer to these problems if it's at the adrenal cortex, so that's like the primary level of the problem. Secondary, if it's at the pituitary, because that is the second organ in the pathway going from bottom up. And then tertiary, you get it, at the hypothalamus. So this could be primary, secondary, or tertiary. We don't really know if we only have the elevated cortisol. However, they gave us a clue. They told us that ACTH levels are low. So ACTH levels are low. Okay. Well, if we have high cortisol and we have negative feedback in this pathway, then the high cortisol levels should be making ACTH low. That's appropriate. That's an appropriate response. And that's how we know that our anterior pituitary is doing its job. So it is not malfunctioning because it is listening to the feedback from the high levels of cortisol. It is not telling you to make more, so it's not responsible for the hypercortisolism. Similarly, we know that nothing upstream is impacting the anterior pituitary because it's still releasing low levels of ACTH. So we know that the hypothalamus is also doing its job and also functioning appropriately. And by that process of elimination, we can now answer our question, which asked us which organ is responsible for the pathology in this patient, because we know that we had high levels of cortisol, but these were appropriately shutting off the pathway above. So we know that our anterior pituitary is functioning well, our hypothalamus is functioning well. The only one that is not functioning is our adrenal cortex. That would be the answer here. Your adrenal cortex is functioning improperly and releasing high levels of cortisol despite the low levels of ACTH, which should have shut off production at this point. So in this question, we had a primary hypercortisolism, which again would be from these adrenals, and that's how you would answer the question. Now I hope this video was helpful, and I'll see you next time.